So CPS explicitly pose a focus on the integration of computation with physical processes, and it is designed as a network of interacting cyber and physical elements. It can be seen through this diagram that in CPS there is always a mix between physical systems and features in each area that supports the CPS. Ubiquitous computing, for example, is applied to machines so that they can be controlled and monitored in real time. Human-machine interface, smartphone, and personal digital assistants are used to interface the machine with workers. So wouldn't it be sweet if we could control all applications in your production system remotely? Like sensors updating their maintenance schedule, machines self-regulating their tool bits, the warehouse tells when exactly should the vendors send in the next shipment, and using which carrier to ensure just-in-time manufacturing, as well as like the HMI or the human-machine interface updating its security updates when the customers are not using them. Or maybe the production system can have a Facebook or Twitter ID where it will update its conditions, like room temperature, electric consumptions, or other things. So in the manufacturing arena itself, that the cyber-physical system plays a huge role to make sure that all the decision-making in the manufacturing processes can be done on the fly with all the information available, not necessarily physically at the factory, but can come from the end user as well as from the enterprise level, as well as from the maintenance guy, and also from the condition of the machines itself. So the horizontal and vertical system integration, among departments, functions, and capabilities will become much more cohesive, as cross-company universal data integration networks evolve and enable truly automated value chains. So the industrial Internet of Things will also enrich more devices with embedded computing and will be interconnected using standard technologies. This allows field devices to communicate and interact both with one another and with a more centralized controller as necessary. And you can see that in these features you have autonomy. Okay, so basically the physical systems have some kind of autonomy, computation, communication, cooperation, as well as modularity. So modularity means like it can be fit into whatever steps of operations necessary, even when you have changes in products. And it's also must be it can also have heterogeneity. Okay, so that means it's not necessarily fit only for certain line of production. But also it has some kind of capability to be able to be fit into multiple lines, simultaneously, or even into multiple lines with different production. It should also have some kind of interaction between physical devices, and it should work towards common goal. So these kind of features, when it is actually embedded in physical system, and the physical system itself can communicate between each other, and also can communicate with the system of systems. Okay, so basically this physical system with all the features or some of the features is defined in this area of cyber-physical systems that have some kinds of degree of mix of physical and features. Okay, so if we take a look at, like, for example, Internet of Services, we are looking at all the services, which means, like, for example, handling or even purchasing services that are communicating with each other to make sure that we are working towards a common goal, which is trying to produce a just-in-time manufacturing without any loss of time during, for example, changing tools or lack of materials in order to produce a product that would be produced at the moment that we need them. Okay, so therefore, we have to make sure that all the field devices or physical systems can communicate and interact both with one another and with a more centralized controller as necessary. So in a cyber-physical system as well, the analytics and decision making are decentralized. So therefore, it is the real-time responses are enabled. Big data and analytics enables the collection and comprehensive evaluation of data from many different sources and customers, to support real-time decision making, optimizes production quality, saves energy, and improves equipment services. So, if we take a look at, if we take a look back at the challenge of mass customization, is we want that to have a lower price with best quality, which is very difficult characteristics to balance, especially when you have manufacturing systems that are not flexible. So if it is if we talk about flexibility of an automation, and it is like the advanced part of automation in previous lecture, we know that it is not necessarily becomes a cyber physical system unless there are communication, not just on a horizontal level, that means between processes, but also on a vertical level, that is from the process towards the middle supervision, as well as to the higher ups, which concerns on the business cost and benefit. So the application of flexible automation cannot completely guarantee respecting the time to market requirements, and compared with the usual short time on the market of the manufactured product. So that's why it must be improved with this cyber physical system. So this actually warrants the necessity of developing and implementing in a complementary manner to address flexibility, fast and manageable reconfigurability of the automation system. Okay, so reconfiguration is very difficult to do if we have a very, for example, a hard variety of the product, and this means that reconfigurability of mechatronics, which is physical part of the automated objects, and the automation software, which is a cyber part of the automated objects, must be put into priority, to enable a smart manufacturing system. Okay, so up until now, we talk about how the manufacturing system has actually evolved into fourth industrial revolution that focuses mainly on mass customization. We're trying to produce products that cater to the individual demand instead of trying to mass produce the same thing to everybody. And I think it is quite prevalent today that we kind of have our own preferences. And we, wouldn't it be sweet if we kind of have like a stream of, for example, production of smartphones that are catered to our own preferences, like how the casing should look like, or whether you should have a beveled screen or not. Or you can have some kind of like processes that you can, tweak and customize according to your needs. Okay, so this is basically the utmost challenge of a manufacturing industry in the era of IR 4.0. So at this point, I think there is a lot of jargon that we talk about, and there is, the term of this cyber physical systems that probably look a little bit odd to the first timers, and you might have encountered all of these systems a lot, but you don't really know the difference between them. So today we are going to just look at these technologies, and I would like all of you to summarize the differences between all of these technologies. So you can take a look at the which one is it? The advancement in ICT, such as cloud computing, Internet of Things, Internet of Services. We even have Internet of Everything today, which is like a superset of Internet of Things and Internet of Services. And you have agent technology and cognitive technology, big data, data mining. All of these are terms that shows advancement in ICT that accompany the cyber physical system in order for it to work as an autonomous system. Okay, so today what I need you to do is simply try to find the differences between this advancement in ICT. So you should actually kind of like differentiate between what is cloud computing and Internet of Things and Internet of Services. Make it in a like form of table to differentiate between all of these advancement. So you have to do it, by yourself to kind of like give you the idea what are this advancement means. Say for example, when we talk about big data, we can only think of like there's a lot of data, but what it actually do is that it kind of like get all of your data, structure it in a form that the analysis and prediction can be done using artificial intelligence. Say, for example, you get like a CCTV stream of videos, and you want to, for example, find anomaly from that. And the way to do that is you cannot simply use successive frames of pictures to predict what happens. So for example, for the artificial intelligence, say using neural network to work to predict something, you have to rearrange the data into like a single column, and then trying to minimize or compress the amount of data that has only the relevant features or relevant data that will support the finding of trends or recognition of objects inside the frame. So big data itself is not simply getting a lot of data, but the intention of that and the technology that we have to support the decision making, because autonomous system is always talking about agents or machines or systems that can do everything by itself. That means actions, decision making, thinking, predictions are all done by the support system that helps the physical system to work autonomously. Okay, so today your goal is to make sure that you have outlined the differences between all of this advancement in ICT that support the that support the CPS to become an autonomous system. Okay, so we have talked a bit here on how the physical system and like some of the features that combine together, that define the area that supports the cyber physical system. So but what I wanted you to differentiate is basically this advancement in ICT. And if you get the table nicely and you have research all these things, you can see that what these differences and how it supports the CPS in order to become an autonomous system. Okay, so I think we stop here. I will look forward to your submission in ULearn. Okay, you have submission link, okay, for inside ULearn for section 1 and section 2, and please do it so that I can count that as attendance for this class. And more importantly, that if you do that, you will get the idea of what all of this advancement in ICT is all about and how it actually supports or accompany the CPS to become autonomous system. Okay, so that's all. See you next week.